Sargent with the Alarm Museum.
And I'm Ralph W. Sevinor from the Alarm Museum. I'm delighted to be here today and to welcome an old friend, MONI MELMAN. So I've known MONI for many, many years, and he's going to tell us an interesting story of technology. And he started from outside of the industry, but over the years got into BDAs and got into RF and component manufacturers. So MONI MELMAN, welcome. It's good to have you here.
Pleasure being here.
And let's start with, how'd you start? Take me for a teenager.
So, for some reason, I always knew that I would be doing something with electronics since I was a little child.
How old?
I think my earliest memory goes to 6 or 7 years old.
Where did you grow up?
I was born and raised in Israel, and for some reason that topic was fascinating me. And later on, a little portion of electronics got me even more curious, which was radio. So those two fascinations turned to become hobbies, and later on it turned to be a profession.
So then, as you went through high school, I assume, and
Correct.
At that point, were you looking at maybe doing that as a career, or more as for fun? Or...
I always knew that this will be my career.
Okay.
I always knew that I would do something
In
in the electronics and technology fields, and the prophecy fulfilled itself.
Mm-hmm.
Yeah.
What did you first set out to do for work?
So my first full-time, so to speak, job was automotive electronics, mainly car alarms, car stereos. I started that as a hobby when I was in my teens, and after my military service, I continued with it. I just realized pretty quickly that there is some room for innovation, and I ended up manufacturing and selling products that I have developed over the years. And I've been doing this for the past 25 years.
Did you find sales easy to do?
Sales were easy when there is no competition.
Okay.
And otherwise, the sales part was not my favorite. My favorite part was the innovation and creating something new. The sales came almost naturally, and that was a pretty good surprise.
Yeah.
Mm-hmm.
Yeah.
Is your background formally in design and engineering? Is that you picked it up?
So I did study electro-optics in high school. We had a specialty high school program. My military service had nothing to do with electronics, so I have no higher education than high school.
So you're self-taught?
Pretty much.
That's amazing.
Pretty much.
So from Israel, and I think I remember Tuki is a Hebrew word.
Yes,
for
correct.
parrot.
Correct.
Right?
Correct.
And so that was one of your innovations, right? Was a Bluetooth enabled.
Correct. So if we go back to...
And this is before it was popular.
Correct. So if we go back to the early and mid 2000s, the automotive industry was always behind consumer electronics.
Right.
So there was a certain delay of anywhere between 4 and 7 years. So when Bluetooth technology was first introduced and became mainstream with consumer electronics, many vehicles did not have Bluetooth and a few other technologies installed from the factory. So that particular latency created a need in the industry for aftermarket products.
And you made a business out of it.
And we made the business out of it. Tuki was one example where, in that case, Porsche vehicles, fully loaded $100,000 plus vehicles, did not support Bluetooth or satellite radio. And we were able to integrate via data bus products that act and communicate with the radio as if it is a factory OEM unit. And that was a very nice success. The product pretty much almost sold itself. It became almost a staple within the Porsche.
I wonder if
industry.
some of those manufacturers took some of your ideas and incorporated it into their mainstream product.
Perhaps, and most likely they caught up. They caught up with consumer electronics, and today the gap is very narrow. Today, most consumer electronic technologies are present in current vehicles.
I can remember, and I'm thinking back because I've been to your lab many times. I remember forward-looking infrared radar,
Correct.
Which today you can buy a car and you have it,
Right.
but this was 10, 12 years ago,
Correct.
right?
Correct.
That no one would ever think of that.
Correct, and that's another interesting story where a company called FLIR, I'm sure many people are familiar with FLIR, now it's owned by Teledyne, was in the defense business for almost forever, and their entry-level thermal imagers were used mainly in military vehicles, light vehicles, light armored vehicles. As the technology became available, they introduced an aftermarket product as well. We were the first company to adopt that product and distributed it in the aftermarket.
And no one did it in a car before, a vehicle.
GM attempted to do it with an earlier, lower resolution Raton sensor, but it was a very limited run. That was on some late 90s Cadillacs. But it didn't really catch up.
And even backup cameras.
Correct.
I remember, 15 years ago, you'd never think of a camera, right?
Right.
In a car.
Yes.
Sure.
And that was sort of your brain trust.
That was our breakthrough, quite honestly, when I've realized that many late model luxury, late 90s luxury vehicles already were equipped with LCDs and GPS navigation, which was also a novelty back then, but nothing more than that. No backup cameras. So that was kind of our introduction to the integration business in the automotive world. Yes.
So if I can take you now, because you're constantly I'm fascinated because you constantly reinvent yourself, right? And one of the things that you got into a couple of years ago was a BDA,
Correct.
a bidirectional amplifier.
Correct.
And so some people may know, some people may not know, some people may not know the benefits. So maybe you can walk me through and then talk about the void that you filled,
Right.
that innovation.
So, and that was a field that was completely alien to me up until 5 or 6 years ago.
How did you first hear about it?
That's a great question. So, as I mentioned earlier, one of my hobbies are radio. And as such, I was an active amateur radio operator. So I kept myself busy. And through the amateur radio community, I have learned about this so-called new requirement that buildings should have or must have radio coverage for public safety first responders. And that sounded a little bit interesting, and I did some reading and some studying, and I realized, wow, it sounds great. It sounds like an evolving market. It sounds like a very profitable vertical that is backed by enforcement.
Code, yeah.
Right?
Mm-hmm.
So it's backed by code, backed by enforcement, and I decided to take a chance and jump right in and try my luck. And so far, things are pretty good. From the very beginning, the system was designed to be on all the time. And in fact, the alarms that are generated, the alarms and the supervisory systems that are generated by the BDA system are then related to the fire alarm control
Through
panel.
the bus.
Through through a
Communication circuit. Or...
through input devices, and then the input devices are a part of the fire alarm system.
So the monitoring center, and the thing I'm trying to get across is this is now mainstream. This is
Correct.
not so the monitoring center would actually get signals from the BDA, low battery,
Correct.
RF lockout, whatever
Exactly,
it may be,
exactly.
frequency.
So on top of the regular alarms that the monitoring company will receive, there are 5 additional BDA specific alarms, such as AC power loss to the BDA system, low battery, antenna failure, charger failure, and those alarms are designated as BDA faults.
So now when a fire alarm company, installation or inspection company goes out, it'll be something that they'll be inspecting as well, if not now, in the near future.
Correct. If a system is already installed, there is typically a service contract associated with it.
Right.
A BDA company, if it's a standalone BDA company, not a fire company, will typically maintain the BDA installation.
Is that a product that you distribute? Is it available at ADI or?
So the industry is changing.
Right.
Initially, there were a few radio companies, radio-specific manufacturers, with the necessary experience in the radio industry. They produced the active components, such as the BDAs, the amplifiers. Other companies, like Corp, for example, provided the cabling, the coaxial cabling required for the job. And typically, those were radio-centric vendors. Recently, there have been a few acquisitions in the market, and lately Honeywell purchased a BDA manufacturer, so they got into the business.
So Honeywell actually has their own now, or acquired?
Yes,
Right.
correct.
Interesting.
Correct. And the distribution channel is changing right now, and more fire alarm companies are getting into the BDA business. There is good and bad in it. But in general, yes, it's closely tied to the fire alarm business.
Is it something that you have to be an RF engineer and know how to use a bird meter and things like that? Or is it?
That's a great question. The answer is yes, absolutely. Unfortunately, today, a lot of the work is being outsourced, and in some cases, it is not done optimally. In other cases, it's done pretty well, and since it's still an evolving industry, there is unfortunately a lot of trial and error and a lot of education that is still needed on both sides, both on the AHJ, the fire marshals, the inspectors, the plant reviewers, and the companies that are executing the project from quote all the way to final inspection. So again, it's a dynamic, interesting market that has not matured yet. There are still changes that are happening. So far, those are all positive changes. Overall, the quality of our industry is constantly improving. Mm-hmm. And I think that in the next 4 to 6 years, it will achieve a certain quality level that we'll all be happy with.
Yeah. Do you have a level of competition?
So yes, there is competition already, like in any industry that is profitable. There is competition. There is some good competition. There is some bad competition. Mm-hmm. Some of my competitors are actually my best friends.
Okay.
And we go out and have a dinner once in a while. My other competitors, they engaged in certain tactics that are cutthroat, low pricing tactics. So yeah. It's challenging, and it's interesting.
Yeah. Mm. So that's today. Where do you see this going in the future?
Definitely nowhere but up. So I believe that.
So this is going to be coast to coast.
Yeah. And mainstream.
Yeah. Absolutely coast to coast and mainstream. So in jurisdictions where those requirements have been active for at least a few years, such as South Florida, parts of California, it is now common knowledge that new construction needs to be inspected for radio coverage, even in the permitting and approval stages. It is known that many states on the state level are imposing certain deadlines for retrofits. One good example
existing
is
work.
Correct.
Oh,
correct. So the initial language or the initial adaptation or enforcement started with new construction. Clearly, there are hundreds and thousands or tens of thousands of buildings that have poor coverage and will need a BDA installed, and it's up to the state to really determine if there will be a deadline, what would the deadline be, and how would it look like, what is the minimum, how many floors at minimum, what's the square footage at minimum that needs to be covered. So Florida is one of the states that currently has a mandate for 2025 to have existing buildings covered.
Wow,
So it's around the corner.
that's around the
That's
corner
around the
for
corner.
sure.
And so, because obviously I can understand Southern Florida, Miami,
Right.
and all, is with the high-rise buildings,
Correct.
where the police or fire come in, ambulance services,
Correct.
they lose coverage,
Correct.
right? I mean, you're pumping out 2 watts or
Yes.
5 watts in the handheld, so you don't have, so that's the purpose of it, to
Exactly.
ensure communications under an emergency situation.
Correct.
In a retrofit, so I'm familiar with Radiax.
Mm-hmm.
Antenna or Radiax?
Antenna.
Why?
Radiating coax, known as Radiax or lossy coax, has a very low efficiency. It's a reasonable solution for
Elevator shafts?
installations like subway trains.
Oh, okay.
Okay, where subway
Right.
and
So it projects
trains
shorter distances.
longer distances,
So-
along pretty much a
Right.
single line.
So there's a lot that's involved because you've got a lot of wiring. You've got antennas now to.
Correct. Yes. So a Radiax or a lossy coax have a very low efficiency. About 95% of the energy that is applied
Is lost.
is absorbed or lost. The same thing with uplink. So only about 5% of the signal is usable for the purpose of an uplink.
So a forward-looking alarm company should be on top of this, at least
Absolutely.
understanding.
Understanding the local regulation,
Right.
understanding the requirements,
Right.
and in a perfect world, understanding how to either do the work themselves or hire the right company to do the job
Right.
from start to finish.
If we can just change gears for a moment,
Sure.
I'd like to talk about, because you actually have your own manufacturing facility,
Yes,
right,
correct.
that I visited many, many times. And state of the art.
Thank you.
It's like a clean room, John, if you have an
Yeah.
opportunity, magnificent. And so we've been seeing difficulties in getting product,
Oh yeah.
right?
Yes.
And everyone says they use COVID as an excuse or semiconductor shortages. And it's almost ad nauseum. All you hear is, semiconductor shortages. What's going on? And when will this be solved?
So the shortages are real, and they're real down to the component level. So if a current vendor cannot deliver a finished product to your door, it is probably because he cannot produce it. Certain semiconductors are still on a 52-week lead time or longer.
52 weeks.
A year. Yeah. And the only explanation that we are given are supply chain delays during COVID completely messed up the scheduling and the production that is necessary to produce those little chips, those little parts that go into a product, an alarm panel or a two-way radio, or even a vehicle today. Unfortunately, we're already at the end of year 2 of the pandemic,
Mhm.
and things do not look at this point like they're improving.
At all.
We see random availability that very quickly goes away. Manufacturers that choose to switch and redesign their product to available product,
More generic chip.
or at least something that is available. You see, the industry is the semiconductor industry is very complex, and there are many moving parts in the supply chain until a semiconductor manufacturer can even release the products from his own factory. There are certain production lines that are limited by the type of manufacturing. Usually you hear 11 micron process, right? It's a certain process that is done in a certain facility, and that particular process is stuck, while an older process may still be viable and running. So even when a manufacturer like myself or a larger manufacturer decides to redesign their product and use some available components, he quickly may find that even those can become unavailable because everybody wants this component right now. So it's a crazy situation right now, and I'm hoping it's going to be resolved soon.
You talked the other day about counterfeit, and
Yes.
that's
Yes.
it blew my. It was just amazing. I never heard of such a thing.
So unfortunately, and without hurting anybody's feelings, Chinese counterfeits are a known problem. Semiconductors have value. Some chips can go for pennies. Other chips can go for $100+ each, even as a manufacturer. So clearly, where there is some profit and a possibility to counterfeit, this practice does occur.
How do they sell that? They sell it on the web or the
They
internet?
they sell it on the web. They sell it through.
So you see this thing, it looks like
shady-
an opportunity, and it's
Yeah.
not.
Yeah,
Brokers,
they sell it
so
through
there's
brokers. Yes,
right?
they sell it to brokers. Some brokers are reputable. Some of them are pretty shady.
Wow.
It's very difficult to know which one is which unless you have prior experience.
And a black market or a not so good chip can end up in a good chip run, right?
Yes. Yes.
You were talking about reels.
Correct.
So you buy 50 reels and 20 of them could be counterfeit.
Yes. Yes. And it's a known problem, especially in. So with government contracts, the problem occurs less. The larger the end customer is, there are certain procedures in place.
They require you to
There's
test.
certain traceability that is required for the product, just like the traceability that is common in the aviation business.
Mhm.
And that reduces the risk of counterfeits actually finding their way to the production line.
So really on the commercial side, like the cameras and the cookies and
Right.
all, that's really strapped you significantly. You've got product that's
Yes.
just laying there waiting for components.
Correct.
Orders unfilled.
And one component, it all it
That's all it
takes
takes.
to completely stop the line.
Right.
Yes. Yes.
That's fascinating. That's amazing.
And you mentioned 52 weeks. Do you actually see that from a supplier?
Yeah. Yeah, absolutely.
You order it and they're saying you can't have it for a year?
Absolutely.
That's
Absolutely.
astonishing.
Yeah.
Wow.
If we can show it on the video later on, we can take snapshots of vendors like DigiKey or Mauser, and you'll see components lead time 52 weeks. They will accept the order, but
They won't deliver.
and in many cases you wouldn't even get it in 52 weeks.
Wow.
Yes.
Wow.
Everything, just in technology, just more of a general technology question. So everything I hear now is it's now software,
Yes.
right? It's software. So where do you see, because it really affects where our cameras and our BDAs and our alarm systems and everything else access, where that's going. So how are we going from a hardware base to a software base? And is that a good thing?
So, well, software still needs to run on some hardware. Hardware is becoming more and more and more capable with time, and therefore cheaper with time, which means that software can sometimes take the place of dedicated hardware. The way I see the future is clearly a transition to much more capable processing. Processing is in the heart of any electronic device today.
Does it have to get better though? I mean, processing
Well,
is pretty good.
Faster and cheaper.
Okay.
Faster and cheaper, more affordable. As processing becomes faster and cheaper, it is worth to invest in the software rather than the hardware. The software is fluid, can change, can be updated, while hardware is pretty much fixed. So a good example is a software-defined radio. You probably heard the term before. What it means is a radio typically has hardware circuitry in it that are designed for the specific purpose. So if it's an FM modulation, there will be FM modulator hardware, and there will be heterodyne receivers. So there'll be a lot of hardware responsible for doing frequency modulation, transmit and receive. A software-defined radio takes all of that and doing it in software. So a raw signal gets into a processor being processed, and via software is modulated or demodulated, and that can be changed. So today it's FM, tomorrow it's some novel new modulation scheme. All you have to do is update the software, not the hardware.
So right now, through 3G is sunset or is being sunset.
Correct.
So we have LTE, we have
Yes.
4G.
Yes.
We have the specs out for 5G, 6G, 7G, 8G. I don't know if any more, but I know there's a spec out for 8G. So right now, from an alarm perspective, you have to roll a truck. So where I'm going with the software question is, do you eventually see where we'll be able to do an over-the-air upgrade from a 4G or LTE to a 5G to a 6G?
So in many cases, that is already the case.
Not in the alarm industry,
Okay.
but I'd like to know where it is.
Right. So we discussed earlier certain hardware requirements. When it comes to cellular and data, wireless data, as long as you do not add new frequencies, which will require new circuitry and new technology in many cases on the hardware side, yes, you can.
But when I'm
you can
changing
push an
from
update.
3G to 4G,
No.
I am changing frequencies.
Correct. Therefore, you
So
cannot update
okay.
the 3G. Most of the phone or wireless modems or cell or data modems that you already using in the last 5 or 10 years
Right.
are software-defined radios. You can actually push a new modulation scheme, release an update.
But not
In
in
fact-
frequency.
Correct. In fact, the same
But you-
chipset is in your phone.
Do you see that happening, that we can change the frequency?
If the technology would be available and hardware will be cheap enough and frequency agile enough,
Right.
then absolutely. Unfortunately, here we also have physics, and you're familiar with antennas. And we know that antennas are designed for a certain frequency.
Right,
Okay, if a new frequency comes, what do you do with the old antenna?
right.
Well, you may want to change it, or you may have some novel circuitry to tune the antenna dynamically, right? There is a physical limitation at some point.
Okay.
I mean, as you go up the frequencies, eventually you'll reach frequencies that are in the visible infrared light area. There's nothing much you can do there with
Right.
radio. Right.
Interesting. John?
This is really new to me, a lot of this stuff, you know?
It's exciting,
and
isn't it?
Yeah, I'm impressed, but also just amazed at the way it's unfolding and you know, the issues that are kind of restricting, you know, it moving forward.
And that's why, Moni, it's great to have you, because
Thank you.
you get to see it from an engineering, sort of a soothsayer, you know, projecting into the future,
Right.
and a practical. And very few people have that ability. So that's why I thought it'd be a wonderful opportunity to
No, thank you.
pick your brain.
Thank you for the opportunity. I think the most interesting part that is clearly observable is, I mentioned earlier, gaps. The gaps between concept and the product are becoming so short.
Yeah.
Technology accelerates in such a pace that a 10-year development cycle in the 60s probably goes down to 3-month development
that's
cycle
amazing.
today.
Wow.
Right? Just think about the space that was needed to occupy a computer in the 60s.
Uh-huh.
And the fact that you have probably more capabilities in your phone than NASA had
Right.
in totality during
Right.
during the moon project. So
Yeah.
the moon, so it is absolutely amazing. It is accelerating, and it's very exciting to be a part of it.
So hold that thought for a minute.
Yes.
What about taking technology moving so quickly and standards moving so slowly?
Right,
Put the two together
right.
and give me your
So
30,000.
I think from the 30,000 feet view, since of course we're governed by regulations, by code, technology will simply become cheaper. If we have to do the same task with cheaper tools, technology will become cheaper. That's the only variable in this formula
But a
that makes
standard's
sense.
gonna hold us back.
Yes, and it may not be a bad thing because perhaps not all technology is actually mature.
Right.
So,
Valid point.
and
Interesting, yeah.
especially in life safety and public
Right,
safety.
well, valid point.
Yep.
I see the other side of it, so you're absolutely right. Well, this is fantastic. I appreciate having you.
Yeah,
Oh,
is
it's
there
my
any
pleasure.
final thought you'd like to say, or?
My final thought is I was very impressed by your very long, almost lifelong project,
Oh,
and yours
yes.
as well.
Yes.
And I'm looking forward to see more of it.
It's great to have you involved in the business.
Thank you.
I look forward to the many years of new technologies you're going to invent.
Yeah,
I hope so.
yeah.
Well, excellent.
Melanie,
Thank you.
it's a
Thank you so
pleasure.
much. Thank you,
Thank
Ralph.
you so much.
Thank
Great
you.
to have
All
you.
right.